So do you guys remember this clip from my video, Hello, my name is Kent Hovind, episode 3?
What he made was 85% tar, 13% carboxylic acid, 2% amino acids. So 98% of his mixture was poisonous to life. I would not call that a success.
We have Kent Hovind there talking about the miller-urey experiment and how 98% of its products were poisonous to life, which is supposed to be a huge problem for abiogenesis. Just to refresh your memory, here's part of my response. You say carboxylic acid, leaving off the S in acids as though to imply that it's one acid and not a whole group sharing a particular trait. And you say that 13% of the product was carboxylic acids and 2% of the product was amino acids. Amino acids are carboxylic. It's possible that you meant that 15% of the product was composed of carboxylic acids and only 2 of those 15% were amino acids, with the other 13 being non-amino carboxylic acids. But your phrasing implies that amino acids aren't carboxylic, which is just silly. And your slide also says that carboxylic acids are toxic to life, which is even sillier. The 85% tar you mentioned probably refers to this. A substantial quantity of polymer or tar was found, perhaps a cyanide aldehyde or mixed cyanide aldehyde polymer. Since I'm not an organic chemist, I don't know if or why this would necessarily be poisonous to all possible original life forms. The fact that cyanide is produced by or found in numerous life forms, such as bacteria, fungi, algae, and plants, would lead me to question that assertion for cyanide, and the nonspecific aldehydes includes, for example, cinnamaldehyde, which gives cinnamon its flavor and is a common flavoring for food. Neither cyanide nor aldehyde seem necessarily deadly to all possible life. And I may be misinterpreting this, but it seems like this says that hydrogen cyanide, aldehydes, and ammonia react to form amino acids, which I've circled in red. To me, as a layman, that seems to indicate that a cyanide-aldehyde polymer could actually contribute to the formation of more amino acids and eventually be mostly replaced by amino acids if the reactions continued. If that's correct, then it seems like the tar could be almost totally removed by being reacted into amino acids long before life ever appeared. So if you really want to beat this dead horse of an experiment even further into the ground by proving that its products would necessarily prevent the formation of life, provide some actual chemistry to back it up. Okay, so aside from the fact that we all know the miller-urey experiment wasn't supposed to prove abiogenesis, there are obviously one or two other issues with claiming it's a problem. But those products still sound intuitively awful, don't they? Especially cyanide. No chemistry could possibly render cyanide or any of these other dangerous sounding chemicals harmless or useful.
God said, eat the fruit, the vegetables, and the seeds. But did you know if you eat the seeds to the fruit, you get a vitamin you don't normally get otherwise? These seeds contain a vitamin called vitamin B17. When you eat a peach, you should eat the seed. These seeds contain a substance called cyanide. People say, oh, that's poison. Oh, now wait a minute. Hydrogen is explosive, right? Ask the folks on the Hindenburg, they found out. And oxygen supports combustion. Who in their right mind would spray hydrogen and oxygen on a fire? Every fireman in the world. It's called water. H2O. See, the cyanide found in this seed is perfectly harmless unless it gets broken loose from the molecule. And the cyanide found in the seeds is perfectly fine. Don't let anybody tell you it's poisonous, okay?
Oh, now I get it. The presence of cyanide is a showstopper for abiogenesis, regardless of any later chemistry or whether the first life would even be affected by it, but chemistry makes it perfectly healthy for Kent Hovind to eat in his peach seeds. How convenient. Episode 6 coming up soon.